So the first one, where's the answer for first one? For structure, what is yeah? How to okay? How what is the meaning of acceleration? Okay, we have a graph over here. Okay, we have a graph. First one, and then 16a explain the meaning of acceleration with the 1 mark. So what's the meaning of acceleration? Who knows? Very basic thing. Rate change of
Velocity.
yeah, rate change of
Velocity.
rate change of velocity. You're correct. So I give you 1 mark for you, Tony. Okay. Number 2, plot the velocity time. You're saying that yeah, something in the chat. Okay, Nikki. Put a velocity time graph of the first 10 seconds of the motion of the vehicle. Okay. So how to do this one? We have I put a graph over here. So we have this as put a, easy if I put a this one as a y. I can write in the I can draw a very straight line. Okay. So this is will be a velocity in meter per second. This one will be in time in second. Okay, so we take 5 as one square as 1 division as 1. Okay, 1 unit. So 1 2 3 4 5 5 1 2 3 4 5 10 1 2 3 4 5 15 and 1 2 3 4 5. This is 20. And then we have in sec time we have 1 2 3 4 5. This is 0 0.5. Sorry, it's 5 seconds. We have to wrong. We erase this one. This is 5.0. 1 2 3 4 5. 1 2 3 4 5. This is 10. 10. 1 2 3 4 5. This is 15. Okay, so we're going to plot. Make sure you have the same shape of a plot like me. Okay, so uh, first one, 0 from 0 to 6 second. 0.6 second. Okay, the acceleration will be 3.0 3.0 second. Okay, that means that the gradient will be 3, right? Gradient will be 3. So that's 6. This is 5.0. So this one will 6.0. So you have 9. How to get 3? 0 to 3, acceleration is 3. So velocity will be the change of velocity over change of time will be
6
equal
times 3
to
by 2.
so it will be 6.0. So actually you have change of 6 9 9 over 6. So 9 over 6. Then you have 3.0, right? Then we divide by 6, you have 3. Eh, is it correct? 9. Change of
So
V.
why 9?
Because you want to get this number 3.0. You can see the
I
numbers.
thought the area under the graph is the velocity.
Area on the graph
Is the velocity.
is the velocity. Yeah, acceleration. Acceleration divided time is the
Acceleration times time is what's the rate?
wait, velocity. So under the graph here, divide acceleration times time. Acceleration times with time, you have velocity. Ah, yeah, correct. Acceleration times time. So v over t equals to a, and v equals to a times t. Correct. So actually, if you calculate, actually you have this is 10, this is 6, so it over here will be ended over there. Okay. So velocity increase from 0 to this point. Okay. Change of velocity. It must be maintained the change of velocity, right?
So the change is linear.
Change is linear.
I thought increasing.
It must be expanding, right? No, exponential.
Yeah,
Exponential.
because the acceleration increase.
So it should be like this shape, right? I mean, this one. The curve like this. Okay. So and then 6 is 12. Will be 10, 11, 12. 11, 12. So 12 should be 15, 16, 17, 18. So it will be around here. Okay. So if you can see that the graph should be like this. Okay. It's not a straight line. Okay. As long as it's not straight. So we have 2 points here. Okay.
So my graph very weird. So
Okay.
my
Okay.
one.
Which
So
way?
can I draw? Like this.
Can you draw on the graph?
More or less like that.
This point is you cannot have like that. This S can see you cannot have like S like that.
Oh no.
Mm.
Wait, where's my eraser?
It cannot be like S like that. It must be like a curve because
It's
it's
somewhat like this.
increasing.
Like
Must be like
yeah.
okay.
It's more curvy lah at the bottom.
Okay.
Yeah.
That's correct lah. Okay. We have only 2 points. We have 0 and 6 and 12. So we have originally 3 points to make up this velocity. Okay.
So for the second part, I don't understand. For the 12 second.
12 second. Actually at 12, acceleration is 0. So you can have this one. So how to tell you? 12 velocity. The total velocity is 18. So let's see if I can calculate. This one is half times 6 times with 3 plus half times 6 times with 3. Right. So you can see half, this is first section A section plus B 6. So actually is 6 times 3, the whole thing. Understand not? The total velocity is half times 6 times 3 plus half 6 times 3 actually is 18 lah. So there you have over here, this is 18 and then it was occurred at 12 seconds. It's the area under the graph. Who was asking that?
hang.
Okay.
Do
Okay,
you
not
understand hang?
understand not? First section, this one
Understand,
A.
sir.
This is A. This is B. So this is
Later I fetch you back
total
hang.
about A, and then B. So A times plus B, you have 18. So total velocity is will be 18. Okay. Actually, I don't think they will be put this question in the STPM. Why we need a graph paper for that. Okay. Usually do have a graph paper for this. Okay. C. Use time velocity graph. It means that this graph to produce a displacement. To complete the table below, and then plot displacement time graph for the vehicle. So displacement we have Vt, and from Vt, V times T is actually displacement, right? So area in the graph, any area in the graph over here, down over here, okay, is actually the uh, displacement, okay, because we know that uh, displacement, you can see that displacement divided by time, you have a velocity. So area in the graph for velocity over time will be a displacement value of the the value of the displacement. So let's say 2 and 4. At 2, 1, 2. So it's over here. Over here we can see that there's only one unit. Okay, one unit. So I can put 1 over here. Actually not very precise, but it depends on your graph. 4.0. So 1, 2, 3, 4 is over here, around here. So from 2 to 4, I make another color. From 2 to 4, here, this part only. To underworld, we can see that is 1, 2, 3, 4, 5. I put as 5. Your number will be a little bit different. I mean, you maybe have a 6, or you have maybe a 7. It depends on your graph. Okay. And then the next one, uh, from this is how much? 4 to 6. So 4, this is 4, 5, 6, 2 over this side, and over here. So actually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I put as 12. 12. And then next one, 4, 5, 6. This is 6, 7, 8. So this is 8. 8 goes up and then goes down. So area under here, okay, will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 35. Okay, and so on. Okay, you continue around. This one will be 10. So this one will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So this will be 32. And number lastly, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay, 36. And then there you have it. Okay, you fill it by how many area is under the graph. Okay.
So,
Hmm.
so like if I'm counting this area, right? You can see yellow color, sir.
Which one? Okay.
Okay. Do I need to count the squares in this area also?
Which area? You mean the yellow?
This one.
No, no, no.
Yeah. If I,
It's on the. It depends. No, it divided by the boundary. So you see, this one is first one. You can see the boundary. Can you see the boundary? This is 2 second. So the boundary is red, and then the
oh,
green between 2 and 4. This is 4, right? So 2 and 4, you just count under here the boundary between 2 and 4,
oh,
and then four
okay. No
to
wonder I'm wrong.
six. You count. You just count how much is uh, the area between the time.
Okay.
Okay. Okay. Now, if you have done that, you have the displacement and then time and displacement. You can do the displacement time graph of this vehicle. You can do this one. You can do it yourself. Like same thing. You make uh take a graph paper, another graph paper, and then you plot it. And this one very easy lah. So there's 5 marks for it. Okay. Any question on the fan? Any question? Any question? One.
No, sir.
Okay. So we are good with it. Okay. Next question is 17. Gerard says, "Sir, I joined the class 10 minutes late as I was rushing back from outside." This is a note from Gerard. He says, "Join 10 minutes late, so now is 4:40, 4:15 plus 4:10, 10 minutes, 4:15, and that's 25. 4:25 now. Now is 4:40. Okay. Ten minutes ago. 10 minutes ago is 4:30. Okay, next one. Uniform circular gears of radius r has section of radius r divided by 2 is removed as shown in the diagram. What is the distance from point P to the center of mass? The disk of the radius r and the disk of radius r divided by 2. So here we have a disk over here with the radius r. Okay, and one more disk. Okay, there's a hole. There's a hole inside. This disk inside this disk has a hole with the the radius is r divided by 2. What is distance from the point P? Point P put as 0, 0 lah, as origin, right? 0. Or this it is only one dimension. This is only one dimension, right? Left to right. No, okay. Uh, for the point P of the center of mass, the radius of r, the disk of the radius r, the disk of radius r divided by 2. Okay. Anyone has the answer? Anyone has the answer?
I have, sir, but I think I'm wrong.
First one, this is one. You see here, it's only 2 marks. Must be very easy, right? It's 2 marks only. Okay, where's the answer? R, correct, Maverick. It is R. So distance from P to the center of the mass. So center of mass for R is this point, right? In the middle, of course. In the middle over here. So radius of R is R. So 1 mark over there. 1 mark. See, it's 2 marks. And the disk of the radius r divided by 2. I mean, the section we have been removed. What will be the distance of center of mass? Who knows? The disk of radius r divided by 2. Okay. So the disk of radius r divided by 2. Okay. So we have actually we have to plus. Okay. This one will be the r. This one will be r divided by 2. So the radius will be the distance will be r plus uh, r divided by 2. So it will be 3r divided by 2. Okay, so for second mark. One more mark over here, 2 marks. Okay, because by center of mass you need to plus. Yes, correct, Maverick. Is 3r 3 over 2r. Okay. Next, any question? No, right. 70b, but consider the base r has a combination of this of radius r2 and the shaded portion of shown in the diagram, or otherwise determine the distance of the center of mass of the shaded. Now we cut off the r divided by 2. Now it's asking where is the center of mass. Okay, so first of all we draw the, it's easier if we draw the r, this of radius with r. So this is this r, radius with the r, and the r. The area will be pi r squared. Okay. Okay, so the mass will be equals to k is a constant times the a. You know that as the area increase, mass also increase. So we put a constant k. For the disk of radius r divided by 2, a small one. This is r divided by 2. Okay. A prime, I mean the area of the r divided by 2 will be pi times r divided by 2, and this is squared. Right. So you end up with a this is not a prime, this is a divided by 4. Where this a came from? It was related with this a is related by this a. See the a prime and a. So a prime equals to a, the big one divided by 4. That's the ratio between them. The small disk r divided by 2 is equals to the big disk of r divided by 4. Next thing is so the mass. Now we're talking about mass. The mass over here. We have 10 minutes time. Okay, I'm going to finish up this one first, and then we see you tomorrow. Tomorrow or Thursday? Thursday is tomorrow. When's the next class?
Thursday.
Thursday. Okay.
Tomorrow Wednesday, sir.
Thursday. Okay. So Thursday we continue. Okay. So mass. Okay, we're talking about the mass now. Equals to k a divided by 4. So this is, you see the first one, the big this is k times a for the small mass is K times 4 A over 4. So area now, this is hardy because we have 3 marks like you see here. Area of resultant, I mean when you add up both of them, okay, is equals to A minus A over 4. This one makes sense or not? A minus A over 4. Do this one make sense on you? The big area minus the small area. How do you get this term? A and A minus 4 you get from the left side. Okay. So A minus A over 4, you have 3A over 4. Okay. So the mass, okay, mass will be equals to 3KA over 4. Okay. So if you if you total up everything, there is KA times R. KA times R. Okay. The whole thing equals to partially by the small I mean by the disk. So 3KA divided by 4, this is a mass, times with the x, the coordinate of the x, plus the big one KA divided by 4 times with the distance, that is 3R divided by 2, and you end up with x. This is the x that you want to find. Actually this part, this is the part that is important. X equals to 5R divided by 6. So the whole thing 3 marks. Okay. Okay. So we stop over here. Okay. And then on Thursday we continue with essay question number 18. Okay. See you guys on Thursday. Okay. Welcome.